I think we're probably good on what an actual process is. I do want to talk about a trace, because traces are some of the best ways to think about your own process as you're defining them. So the trace is the sequence of actions you're allowed to take, and I'm going to set up a very simple example to start with this actually. How do I do big text mode? Big font mode. There we go. Okay. We are going to make a simple light switch to start. So we'll start with some states. So in LTSA, you get to define a state, and you give it an equal sign, and you will tell it what actions you are allowed to take from this state. So when I'm in the on state, the only thing you can do in a switch is you can flick it off. So we'll have an action that we label as off, and we'll do an arrow, and we'll tell it what state it goes to. So in this case, the off action will take us to a new state that we will call off, and then we can put a comma and create another state. Down here, we actually need to define what off does. If I don't do that, if I just leave it like this, it's going to be not very happy with me and say off is defined to be error. It doesn't know what off is supposed to be. So we'll tell it that off will actually, when you're off, well, you can run the on action and you can turn it back to on. And now that should be good. And we've got a nice little cycle where it can take one action to go to a different state, take another action to go back to the initial state. Now, let's say you don't really want right now it labels your switch as just on. That's its name. It just labels it based on the first state you give it. So if we want to rename it to something else, all we have to do is we just have to write in the actual name what we want our process to be called. I'm going to call this process switch, and I'm going to give it a state that it will go to. So I'll tell it that the switch will start as off, and then I can just write a comma. So now it knows that the switch actually starts as off, but what's nice about this is it'll actually call it switch now instead. So the first thing you can do with your switch is you can turn it on and turn it off and so forth. Now what I really want to show that'll be very helpful with the assignments is the animator. If we hop over to the animator over here, you can actually see it gives you a little checklist of your different actions. So initially this will just show every single action you have in your system, any action you've ever defined. But what's cool is the checkboxes show the ones you are actually allowed to run. So if you click on, then you can run on, and now it changes. You can actually go back to the diagram and you can see it's moved us, the red state is the one that we're in right now. It has moved us to the on state. And now the only action I have from here that I can do is I can click off, and now once again I'm in the on state, and now I can turn it back, or I'm in the off state, and I can turn it back on, and so forth. So I find the animator so much nicer. Once you start to get really messy diagrams like this, if you guys have started the assignment, you've probably already seen how messy some of the solutions can get. Rather than trying to look at your diagram and decrypt if you've actually done this correctly, I find just testing with the animator is so much nicer. Just look at the question, think about the kind of behaviors your solution should have, and you can just kind of run through this and make sure that your program actually follows the behaviors you wanted it to have. Okay, are there any questions about that simple LTSA example? Because if there's not, then I want to move on actually to my first example, which is we're going to try to program searching a array with linear search in LTSA, because this is a bit more of a complicated example. I figure if you guys have gone through the slides, most of this should be pretty clear. I'm just going to quickly check the Discord. Doesn't look like we're saying much. Okay. But yeah, so feel free to stop me anytime if I do anything in LTSA that's syntax you're unfamiliar with, anything like that. I'm going to try to explain what I'm doing, but again, feel free to stop me at any time because questions are very, very helpful when I'm trying to teach how this stuff works. I don't always know exactly what's confusing. Okay. So, because this will be pretty helpful for one of the assignment questions, I think. We are going to try to search a array with linear search. So we have an array of some size n. So maybe we got 3 items. Bada bing, bada boom. We need to search it from starting at index 0 and go all the way to index n. And at each index, oh, I guess that should be. I forgot how 0 indexing works. Don't worry about that. At each index, we either find the desired value. So as we're going to each one, we'll either find the value we want and we'll return 0, or if we find it here, we'll return 1. If we don't find what we're looking for, then we'll keep going to the next one. And if we get all the way to n-1 and we don't find what we're looking for, then we'll need to give an error. So let's look at how we can represent that with LTSA. I wrote this question. I haven't solved it yet, so we're going to see how this goes. I might be a little rusty. To start off, I'm just going to make a state called the array. And this is going to be a good example to talk about basically indexes. You can give your states numbers. Essentially, what I want to show off is that you can do something like, one way to do this would be to hard code every state. Let's say I want to do an array of size 3. Then I could technically do, I could have array 0 is, you know, the things, and then here I list the actions you can do when you're at index 0. So if you're at index 0, then your options are either, you could find, how about, well, we could call something like find, you find it at 0. So you tell the program that you found it at 0, and then that'll just go to stop. You're done now. Stop is a pre-built state. This is also pretty important to highlight. Stop is already a predefined state. So if you want your process to just stop once a certain action is taken, then just use stop. You don't have to write a definition for what stop is. Or you could do you could do next, which takes you to array 1, and so forth. And let's say if you really wanted to, let's say it tells you to define this for an array of size 5. You could do this. You could just keep doing this for every single possible option. But that's terrible. So rather than doing that, right? Rather than, you know, oh yeah, find it 2 and then go to 3 and so forth all the way until the end. We can do ranges, which will do this for us automatically. So we can define a variable. I'm going to say this variable can range from, we'll start it at 0. This will be our indexes. So our possible indexes will start at 0 and then go all the way up to, let's say 5 for now. And maybe we can expand that later. So what I will do then is, let's say, I'm gonna change this a bit. What do I want to say here? We'll call this return because it's like returning a value. And what you can do is you can actually give the action I. So this will actually create an action. If I remember how this works correctly, this should create an action in the animator called like return.0 or return.1, which kind of represents like returning a value, which is nice.
Oh, we have a question.
Oh, awesome. Other than stop, I can't think of any useful ones aside from, I don't, there might be one just called error. I can't remember really. Nothing important that you need to know at this point in time, from what I can remember. I think stop is the only important one at the moment. I feel like there were some other syntax things when it came to. I'm not gonna. There's more stuff. LTSA. This is like the basics of LTSA, and my brain is going through all this nonsense you guys get to later. That works more with the error state, but I don't think you need to worry about that for now. Okay, so short answer is no. Okay. And then you can also, you don't have to just use I, but you can do math in here, kind of like any programming language. So you can even make it that next will send you to array I plus 1. Now, this on its own should give us like some errors actually. It'll not appreciate this very much. If I go to compile this right now, oh, also, your initial process, when you try to make a process, you can't just start with a process with an index. So, because mainly it needs to start at some state, right? If you do this, it doesn't consider, you know how before I had it set up so it was like array 0, array 1, and so forth. In this case, it was obvious that array 0 was my first one, so you would expect it to start with an initial state of array 0 when I go to run it. But when you do it with this index, it doesn't do the same thing. It doesn't actually consider 0 to be the first state anymore. It just gets confused and doesn't know what the first state is supposed to be. So we'll just define one called, how about search? I'll call it linear search because that's what this is. We'll call this linear search, and we'll say that this equals array 0. You give it a specific number that it equals. So now we're gonna get some new problems. So I fixed this. It's okay with this issue now. It knows to start at 0. If I go to draw, it does actually work, but I get some weird stuff because I have this -1 state. Look at that. I've got -1 over here. So what it started to realize was if I do next a bunch of times, eventually I'm going to get to array, if I is 5, right? If I do next 5 times, so I'm looking at the 5th index of my array, right? I'm at array 5. Then if I do next, I'll get to array 5 plus 1, which is 6. But I've told it here that the range limit for I is 0 to 5. Right? I don't want to be able to index out of bounds. That's what's happening right now. It's trying to go to the next index. It is indexing my list out of bounds. So to fix that, we can actually add some guards. Now, if I'm going to add you can add a when statement. Now, I'm going to change my formatting a bit. The way I usually like to do this is right before the equals. This LTSA is not that picky with where you start to enter your lines. So I usually like to format it like this. If I've got a big sequence of actions, I arrange them like this. Because then what I'll do is after each guard, like anywhere here, at any of these points, you can drop in a little when statement. This when can just be some kind of, it's basically just an if check, and you can check what this I value is at. Which means if you want to do something at the first index, something special at the first index, you can check if I is equal to 0. If you want to do something at the last index, you can check if I is equal to, you know, your last number here. So what I could do is I could say when I equals 5, when I is less than 5. That's what we're trying to do. We're trying to make sure we can only do this when we are not at 5, when we're not at the end of the array, right? You can only go to the next item if you're not at the end of the array. So if I compile that, that should be good now. Let's go check out the animator and see how this looks. We can check out the state machine, but again, this is kind of awful to look at, and I find this so much easier to test. So at the beginning, you'll have to check index 0, and maybe you'll find it immediately. Maybe the first thing you'll do is you'll actually just return 0, and you're done. Or maybe you'll just go to the next one. Maybe you find it at 1. Maybe you don't, so you can go to the next. Again, maybe you find it at 2. Maybe you don't. So maybe you find it at 3. Now let's say we don't. We keep going. Now I can't do next anymore, which is good. But interestingly, it forces me to return it at 5. What if my item is just not in the list? That's why in the instructions I have that if we don't find the value at that last index and -1, then we need to give an error. Okay. Oh, also, is that how this should work? How many times did I push this button? 1, 2, 3, 4, 5. Yeah, because I'm starting at the first one. Sorry, I was thinking about, like, am I actually doing the indexes right? But yeah, it's because I started the first one is 0, and then I did next 5 times. So I'm at the 5th item. So my array, because it has indexes 0 to 5, so it has 6 items. There are 6 items in my array. Technically, if we want this to be an array of size n, let's say n is 5, then that should only be up to 4. And okay, now I'm going to introduce something else I wanted to mention, which is variables. It's often good, you'll see this all the time, where he gives problems where it's like, okay, we want to model this with like 6 different computers working together. In that case, you often want to create a variable at the top that models that number he's given you, because it's much easier to test a process when you only have maybe 2 things, maybe an array of size 2 or 3 or 5. Let's say he told you the array should be of size 100. You don't want to be having to work with 100 states in the animator if you want to test the end of the array. And you also don't want to be changing every instance of 4 to 100 when you're done. So we'll make a variable. I know, I'm explaining the usefulness of variables to COMPSCI students. Anyways. We will call this just n, and I'll set this equal to 5. So what I can then do is I can say that my array will go from 0 to n-1, and I'll check if I is less than n-1. And I want to make sure that still works. No, I think, oh right, constant, it has to be uppercase, and that's all. I forgot about that. So I think that should work properly. Cool, okay. So now, even though I gave it n equals 5, it only goes up to 4 states. So once again, let's go back to the end behavior. Once I run next 4 times to get to the 5th item in my list, then I can try to return 4, but let's say I don't want to be able to find this. I don't want to find this element. This element is not on my list. Then I need to also be able to return an error because I didn't find it only at the end. How about we'll say we'll return -1. Maybe we'll return -1. So I'll do one more pipe here, and we'll add another when, another restriction, because what I don't want to do is I don't want to just put that you can return -1, because then you can just do it at the beginning. Also, is that even going to work? Oh yeah, it has to know what to go to. So I can say it goes return -1 to stop as another option. Maybe I did not want to compose that. But if I do that, then now I can just return an error at any time. And technically, I should only be able to error if I get to the very end of my list and find out that my element was not in there. So what I should do is say I can only error when my I value has reached the very end, which means my I should be equal to n minus 1. So only when I equals n minus 1 can I return my error, and then I stop searching the list. And now I believe, I keep hitting this button, I believe we have finally set up linear search in LTSA. We can check, we could find it here, but if we don't, we'll keep searching. We don't find it here. Let's say we don't find it at 2. Let's say we don't find it at 3. Say we don't find it at 4. Now I have the option of either, or sorry, let's say we didn't find it at 3. Now I have the option of either I didn't find it, or I found it at 4, or if I didn't, then I didn't find it at all, and that's our error. So you'll see what we're not really trying to, when you're making an LTSA program, you're not really trying to make an actual program that solves your problem. Like, I'm not actually making something that searches an array at all. You're just trying to make a process that, or a state machine that models the behavior that a linear search algorithm could follow. So at every state, every possible state the algorithm could be in, you want to make sure that all the right actions are available. So at the beginning, I either have that option of immediately finding the value or going to the next item. I can find the value or go to the next item, find it, go to the next item, find it, go to the next item, and then find it or don't find it, and we're done. So I hope that example made sense to everyone. If there are any questions about that, please let me know. Mainly this is meant to be helpful for the radio question. I think the radio question is a scan procedure that's a little interesting. It was definitely confusing for me when we had the same question. I remember. It's funny. Also, I think some of your questions are from our midterm. It's interesting how we kind of mix and match.
Don't tell them that. Don't tell them that. You'll stress them out.
No, I mean this is easier. I wish we had it on our assignment instead of the midterm. Are you kidding me?
Oh, somebody's asking, do we have to use arrays for the radio question, or?
No. This is, you should be, or I think, okay, if I understand what you're asking, I should also clarify, this is just a state name. So this could be something called like scan. But if you're just asking, do you need to do this ranges setup at all? Then yes, as far as I'm aware, you do need to do the ranges. You should be having a range to model the frequency that you're at for scanning. I'm just waiting to see what Philip says because I want to clarify if I'm interpreting that correctly. Yeah, it's like, just keep in mind whenever he gives you a number, like he wouldn't give you the frequency if it just didn't matter, if you just had to keep doing scan a bunch of times. So it's actually important that you limit it to only scan a specific number of times, based on the frequency values he wants you to check for. So you should be modeling the scan using the range somehow. So I thought it'd be nice to go through an example of kind of how you manage this. And you don't always need something like this that actually returns the number you're at every step of the way. Like this could just be like how about found? We could just do found instead. And this could just be not found, something like that. So I'll compile that real quick. So this would also work, right? At each index, you either find it or you don't, and you go to the next. But what's special about, like now at this point you might be thinking, do the numbers even matter anymore? But they do. They're invisible, but they are limiting the number of times I can go to the next item until I actually have to say that I've either found it or not found it. So it's not just an infinite process. Otherwise, you could have done the scanning with like, oh, you know, you can scan to the next station and either you keep scanning or you stop, and that's it, that's all you program. But at that point, you'd be able to scan forever in an infinite cycle when that's not technically possible. So each of your scan actions doesn't necessarily have to have a label, as far as I'm aware. But yeah, it's important you put a cap on how many times you can scan until you've reached the bottom and you have to, hit the reset button or however that question worked. Yeah. Okay, any other questions? If not, I'm going to talk a bit about concurrency. I'll talk about shared actions and all that, and Petri nets. Woo! I'll just give like another 30 seconds just to see. And nothing's going on with these channels. Okay. Okay, I'm actually too impatient for 30 seconds. We're going composition, baby. Okay. So, composition. We will have two different processes. So, for example, we could have a maker process. And you'll notice the red actions are what we will call shared actions. So we've got maker, which pretty simple. It just takes make, takes ready, and goes back to maker. Oh, I guess I should also show this off. One thing I'm going to do is I'm going to quickly copy this into the notes here so that you guys will have this. I'll post this document. I think I'll probably post this document. But yeah, so I'll include the solutions to each of these. Yeah. Okay, just because I wanted to clear this off. So what I wanted to show off here was just in case anyone has not messed with LTSA much, I want to make sure this is clear that what I'm about to show, these two things are equivalent. We have to do brackets in LTSA. Oftentimes his FPS or his FSPs won't do that. But you can either do make, and then you can make a state here. So let's call this made. This is you've now made something. And then made can then, now that you've made something, now you can ready it, and then the maker can make something again. You can say it's ready, and so forth. So this, if we quickly compile this and run, as you can see, it follows the exact path you'd expect it to. You can make, you can ready, and you're back. You've reset. Actually, if I show in the diagram as well, right? You can see you make, you ready, you're back. It's basically just the on-off switch. So that is the exact same as, oops, in LTSA will allow you to do this too. You can also just get rid of the middle guy and just do that. So you can tell it maker just runs the step, runs another one, and goes to maker. And so LTSA will actually make a intermediate step here. It will actually make a state. This does make a state. You haven't really saved yourself any states, but it's just a faster way to write out the same result. So yeah, you can see it still does the exact same. You can make ready, and you're back, you reset, and you can see the same in the diagram. You can make, you can ready, and you're back. So it did make that extra state. So 0 is the maker state, and then 1 is this intermediate state between make and ready. The only reason you would want to do the other way is if perhaps from this other state, from state 1, you wanted to be able to take some other transitions too. That's important. So in this case, we'll just have maker, and then I'll type out user as well, because I'll probably want to show off composition in LTSA in a moment. So we can do ready, got use, and we got user. I got two processes now, and it'll compile both of them, and they both have their nice little diagrams. Oops. Okay, now composition. I don't know why this is in lowercase. It should be both in capital. Composition, we combine maker and user, and now they are both running in parallel. But what's important is that they have to wait. They have to run their shared actions, the ones with the same name, at the exact same time. So I'm going to show this off first, I think. If I were to now compose them, I can draw the composition out here. And let's look at what this diagram represents. So let me bigify this. There we go. I think I can zoom in a bit too. Nope, I actually can't. That'd be too much. But you can at least make it bigger. I'm hoping that's big enough for everyone. I don't think I can really make that larger, unfortunately. Yeah, I can't. Okay. So you'll see, let's look at this. So for example, user. If we've combined these two and they're running in parallel, you would normally expect that user could choose to use the ready action right away. But it can't, because maker also wants to use the ready action. That's a shared action, which means they both have to be at that step where they're ready to do it. They both have to be at that step where they're ready to do it before you can run the ready action. So maker is going to have to do make first before they can both do ready. So it doesn't matter that one of them has to be ready for it. They both have to be right at the step where they're allowed to use it. And Petri nets are used to make this a bit easier to visualize. So converting a single process to a Petri net is a pretty simple process. You basically just put a box on every single transition, and we have a dot that you can think of as the current state marker. So essentially these dots, oops, I'm just trying to go to the next slide. Oops, there we go. These dots have to get consumed to go from one transition to the next. And in Petri nets, a transition will have multiple different dots, or maybe just one, but it can have multiple dots. Any arrow pointing to the transition is a space that needs to be filled with a dot for the transition to run, to fire. And then after the transition fires, it will put a new dot in every single place that has an arrow coming out of the transition. So, For most cases, when you're modeling a single process, it's going to be a really simple transition because it's just going to have one dot that goes from one state to another. Because you're just modeling the single process of maker firing. These dots are just supposed to represent processes. And then a transition that needs multiple dots is a transition that is shared. It's a transition where multiple processes need to be loaded and ready to run it before you can actually run this transition. So as we can see in this diagram here, ready needs a dot in both this state and this state to fire. And what's interesting is they don't both start here. This is just like we were talking about before. You can't run ready off the rip because maker, this is the maker process here. This is the exact same FSP as we see right down here for maker. It's just, you know, rotated 90 degrees. But we can see that the dot starts in 0 because it has to start here where it has to make first. So once you run make will consume the dot, fire the transition into this slot, and now you have both your dots ready to run the ready transition, and it'll put a dot here and here, and the process can repeat. So to do a full cycle of this, a full cycle of make, ready, use, you'd have to have maker can make, and then they can both run ready. So you've got your dot here and your dot here, and then user can do use again, and now the dots are back where they started. And you could do that cycle again. So any questions about composition? I think this is a pretty good example. You guys have also probably seen this already from the slides, but I wanted to go over it just in case because it is very, very important course concept. Originally we were planning to do this as a nice little group activity in person, but I don't think it works out too well with the online setting. So I'm just going to walk us through this one as well. But just a simple example that we created. Oh, wait. Yeah.
Let them. No, let them. Guys, do you want to try to do that on your own for like 2 minutes and then we take up the answer?
That's probably still fun. Yeah, I'm down. Yeah.
Yes. Let's do that.
Okay, so give it a try and just keep in mind that each process, you should be thinking of each dot as its own process. So try to kind of trace a path for this dot through the diagram and figure out where just the one dot might go. And that'll help you get an idea for what a single process should look like.
Jacob,
yes.
Go to YouTube and search up Kahoot music while they solve
I'm not
the
putting on
question.
Kahoot music.
Oh yeah, send a screenshot of that here.
Sounds good.
Because they don't have access to
it. Yeah, because I'll just post. I'll drop a quick screenshot of that in the channel.
That's a really good question or a request. A good request, Philip.
Okay. Also, the handwriting is not the best. I'm sorry, Jeremy.
Okay.
That is an A. I believe that's an A in the big transition.
Actually, Jeremy and I were talking about how his A's are a little funky.
It's like on an angle. It's like on a 45.
Yes, he writes them backwards. I don't know how to explain it.
I forgot to start the Kahoot music. Hang on.
Yeah, sorry. Kahoot music. You guys, lock in.
Nice. Okay. My cue for when to stop is when the Kahoot music ends, so in 10 hours.
So the health session will end by then. That's okay.
That's okay. I'll still be here, vibing to the Kahoot music. No, I'll stop at 7:40 and we'll discuss. But
wait,
I think going through this oh yeah?
Sorry, the question is model the Petri net as a... Or copy and paste the question text?
Oh,
Maybe.
It's up to you. Honestly, whichever one you think might help. The question itself was model it as an FSP. Also, this music's really louder than my voice. Yeah, I can tell in the recording. It should be 2. So the big idea is because there's 2 dots, you want to decompose it into 2 FSPs. Each dot, the path that each dot would follow will kind of represent one FSP. This music is still irritatingly loud. Pretty much, yeah, not a particularly complicated process, but I wanted to go through because I think there is a question that's like, do this same process for something from the slides. And also a lot of our midterm questions were like, hey, make an FSP for this, or decompose this Petri net, sorry, make a Petri net for these 2 processes, like the reverse, or decomposing a Petri net into processes. But yeah, you're essentially just following the dots. I know it gets a little weird when you've got the two going in at once, but especially with the way it's drawn, it's kind of clear which dot is supposed to go where. Sometimes it takes some intuition to understand what kind of system the Petri net is supposed to represent to figure out which dot goes where. In most oh yeah?
Sorry, I was just gonna say, for the record, you guys can unmute and ask these questions if you think it's easier than typing.
That is also very true, yeah. Yeah, so actions can have, this is actually intentional, transitions can have the same label. There's no real, it's just like in our FSP, you could run like found twice. You could have, when I was making my array thing, there's no reason I couldn't have done like found, arrow, found. It's completely valid. There's nothing wrong with that. So it's the same for these. There's no real reason. The labels are not that important. They're just action labels. So I don't think she's being sneaky, sending me a Discord message. I'm not. Should I be opening this?
I'm looking at my notifications.
How are we supposed to write the ones where there's two arrows coming out of it? Like there's a choice.
So I think in that case, it's best to try to. In this case, I think it's more clear
Like
because
CD,
you can kind of figure out. No, go ahead. Yeah. Did you
Like
said,
CD,
wait,
for example, the dot could like go both ways.
Yeah, so in this case, it's kind of unclear whether the dot goes this way or goes this way.
No, not that one.
Oh, not that one? Are you talking about the E?
When it
or...
have two arrows coming out of a circle.
Oh, I get what you're saying. Okay, that's an option. So that's, as an FSP, that's if you do the pipe, because you have two options at that state.
But then how do you write it on one line?
So
Like,
typically in LTSA or as an FSP, we would write, just for that specific example, let's say that is state P. Okay, I'm calling that state P. Then we'll write it like I'm about to send in the chat. We would do goes to C, goes to something, or D goes to something like that. So the question marks are just where C and D are actually going, whatever you want to call those states. But that's the idea. Is you just do a pipe, you have options at that state. This game music is literally annoying me. I'm turning this shit off. If anyone is finished, if you'd like to drop your answer in the chat, you can. If you know how to spoiler tag it, go for it. I'll rate your answer. No, I mean I'll just let you know if you got it or not. And it's just an indicator for me for who's done. I'll give it till 7:45 and then I'll take out my answer. Oh, we got one. Okay. Okay, I'll just start looking through this then. So we got, I'm just gonna kind of highlight it here and post it in my little text bar. Also, I can zoom this in a bit, can't I? Yeah, that's better. Oh, beautiful. Oh, that's perfect for the recording. Oh yeah. These are the Discord proportions, I remember. Okay. So we'll have P1 can take A, and then you can go to B. Okay, now the issue with this, Philip, is so B is lowercase, so it's an action. I assume you can see what I'm kind of typing here. You should have another state that it goes to. So it should go back to P1. Same with E here. They have to actually go back. They have to go somewhere. You can't just end with a single transition. So, like, that seems fine. And it's the same with D. So once you reach the end, you actually have to do another, you have to write P2 again to kind of loop it back, to tell it where to go. And with E as well, E should loop back to P2. So I'm just going to send that version. And then let me look at this other one. Okay. So we'll have A goes to P1. Okay, so you're doing it differently. You're actually naming your states, giving each of these little names. So P1 seems to be this guy. No, okay, so you've set P1. P1 is this one. Awesome. And then we have C goes to P2. And then P2 can take E and go back to .1. Okay. And then D can go to P3. Wait, did you forget to finish P3? I think you forgot to finish P3. Yeah. It's all good. Yeah, it helps once you finish something like this to just kind of go through each state and double check and make sure you've actually defined the processes at that. Double checking this stuff is pretty important. I feel like I don't normally double check my work that often. I'm kind of lazy like that, but there were a lot of times, this was one of the times I had to check my stuff the most often, and like I caught the most mistakes. Like sometimes I don't really check like my math work because I'm like, even if I made a silly mistake, am I even gonna catch it at a quick skim? But I feel like so often you catch little things you missed when you do these. Okay, and then you've got A goes to Q1, that's the other dot, so this is called Q1. And then Q1 either takes B and goes back here, yeah, or takes E and goes back here, and those both work fine. Yeah. So, but yeah, I think the only thing to add for this would have been P3 equals, and so after D, it's just another D, and then you're back to, oh yeah, you can do .1 as well instead of, sorry, no, it should be .1, yeah. And that looks good, I think. So I'll just send that one too. Okay. And then the one other thing I'll just show with Philip's solution, because it's good to talk about, is there's kind of two different ways of doing this first part. Let me just look at P1. You could have done it like this, or like even if you don't want to make extra states, you have another option here. Because right now you've said that P1 basically takes the sequence A and then B, or it takes the sequence A and then E. But you can actually change that a little bit. You can say it will take the sequence A, and then it will go to this. It'll either B to P1, or it'll E to P1. You can kind of simplify your diagram or your FSP a little bit like that. So you're saying basically A goes to some state that then does these processes. So you can put nested brackets to simplify the fact that they both start with A. We're basically I'm factoring out the A pretty much. So I'll post those two next to each other. But yeah, I just think because sometimes it was just really nice when I was doing the actual like word problems to simplify what would otherwise be a much messier diagram. Okay. Well, I think that's good for that then. I'm gonna zoom back out a bit now. Probably just that is fine, so people can at least read questions. Okay, and I got more to do. So I think that was all for the slides. Yeah, this is their final answer. And then of course, if it asks you to model the PetriNet as a composition of processes, you will want to put your little composition thing at the bottom. So our final process is you call it like this is part of the name is the two pipes and then whatever you want to name it. And then in LTSA, you just compose things by putting both of their names. So if I'm going to do the composition of these two, I can compose them as make your user equals maker composed with user. And I think that, do I need brackets around this? I think it's weird. It's like, I think I need that if I'm not crazy. Yeah, that's what it wants. And it'll like this. So you'll notice that without this line, it still like composes properly, but it just does. I don't get to name it, and I don't get to control what composes. So let's say I had a process here for maker, and then I want to compose it with two different users who can each use, and they can use something independently of each other. Then composing that gets a little weird if you only have the default composition option. So this actually lets you compose with user, and then maybe let you compose with something else. I'll get into labeling actions later. You only need one user process to basically define multiple users by putting some labels on their actions. There's some stuff to make a user that'll do every action with A, the letter A before its actions. But as far as I'm aware, you don't need that for this assignment, so I'm not going to cover that just yet. That'll be probably at our next session. I'll talk more about relabeling, because relabeling gets pretty complicated. Okay, I think we're all good on that, so I'm going to go on to my other example from here, which is the cookie tray. Now that we've talked a little about composition, let's do a nice LTSA example with some composition. So, and it's just going to be more practice with the ranges as well. Okay, so I'm going to start with, we have C cookies to fit on a tray. So just like before, but I'm going to do this right off the bat, I'm going to set C equal to something like 4. I'll have 4 cookies on my tray. And now I can start setting up the actual processes. So for something like this, the first thing is just identifying what our actual processes are in this situation that are running in sync. So not running in sync, running separately, running concurrently. So we have a tray. It seems the tray has its own little individual actions. You can put cookies on the tray, and the tray can be baked. And you put the tray in the oven. And then we also have an oven. An oven can be preheated, so it's got its own actions as well, right? You can preheat it, you can also cool it down, and you can put a tray in it. You can bake actions, or it can bake batches. And from there, it becomes kind of clear what our shared action is. It's clearly the baking. It's the oven has the tray getting put into it, and the tray gets put into the oven. So yeah, we can see here it gets composed on transition bake. That's our shared action. Not every question will tell you this type of information, so you'll often need to identify, okay, what seems to be the shared actions in this case? What needs to be the interaction between the two? And sometimes there'll be kind of useless information, like something like the preheating is important. The preheating, logically, we can assume changes whether or not you can bake, because you cannot bake in a non-preheated oven, right? If the oven is cooled down, then we can't be baking anything. But sometimes they'll actually just be these processes that have useless information, like, oh, the philosophers can think, and you still have to model it. Don't leave out the useless information. I would lose marks all the time for just forgetting to add those, but not every process or not every action is necessarily going to be required for it to do the shared actions.
Wait, sorry, have they gotten to philosophers yet?
I don't think so. I know I made a reference, but I immediately realized I'm like, they haven't actually touched on that yet.
This will make sense in a few weeks, guys. Okay, sorry to interrupt. Keep going.
No, all good. But yeah, let's say the oven had some other actions that are clearly unrelated to the cookies, like those, that could be in here. Okay, so we'll start with modeling the tray then. In this case, I think our processes are just going to be our objects. We'll have a process for the tray, and we'll have a process for the oven. So I will make tray, and it seems like we would love to have tray. Tray should be able to, you gotta be able to put a cookie on it. So maybe we'll do cookie, will be our action where we put a cookie on it. And that should come back to tray. Natasha might be freaking out right now, but I know what I'm doing. Just, or we can bake the tray. And that may also just come back to tray. Problem with this is I can do whatever I want immediately. I've put no restrictions on any of my actions. I can just cookie or bake whenever I want. So I can just bake right off the bat. I can toss them in the oven immediately, empty tray, which is not part of the question. The question says it can only be baked once the tray is full. So once again, like our previous question, we're going to need to use some indexes. We're going to need to have a variable for this. So I'm going to make another variable called I do a colon, and I give it my range. So I can have anywhere from 0 to C cookies on my tray, right? Because my tray only fits C cookies. Now this means whenever you send something back to tray, you got to tell it what number you're sending it to. So when I want to add a cookie, I actually want to go, I'm not always going to the same tray value, right? I'm going to whatever it's at right now, but I want to add it by 1, because this is my command for adding a cookie to the tray. So here I'm going to go to I plus 1. So the range is just important for LTSA, but you can almost perceive it like this. It's kind of like a recursive formula. You're telling it the tray I, after taking cookie, will go to tray I plus 1. So if this helps to visualize, that's good. Unfortunately, you do need the range there. It does need to be there, or LTSA will not be very happy with you. But this is what you should be visualizing it as, is you're giving it instructions for where tray I can go to. So in this case, tray I can only go to tray I plus 1 if it takes the cookie action. Now, we need to put a restriction on bake. So I'm going to do what I was doing before, where I kind of enter this all down. I like the way this looks better. Like that. Because then it's kind of nice. It's all lined up, so you can put a when wherever you want, and they all look the same. So we can do a when, because we need to restrict bake. Cookie is fine for now. Bake is the more obvious one to restrict. We are going to need to restrict cookie. You'll see in a sec. So for bake, we can only bake when we have a full tray, which means we must have I equals C, which is our max value that we can fit on a tray, right? C is how many cookies we can fit. So if I equals C, then our tray is full. So again, this is like a formula for I. This is, we reached our max. We're saying normally, no matter what the value is, you can take cookie and go to tray I plus 1. But if this I happens to be 4, if it happens to be the max value, we gotta add an additional action where you can bake, and we should probably go back to tray 0, right? You've emptied the tray once you start to bake.
There's a question in the chat, Jake.
Oh, thank you. Yeah, it'd be just modeled by like a self loop action, yeah. Or maybe it's a useless sequence of actions. Maybe you have to take all 3, and they actually maybe they do kind of restrict you from doing something. Like you could kind of. I think it'd probably be obvious based on the question, but that was kind of what I was referencing. Yeah, there might just be some self loop actions that immediately take it back to the state where it can do whatever it needs to. Maybe I'll try to add one to the oven as an example once I'm done. Okay, so this is looking good. We can bake, we can go back to tray 0. Now when I go to compile, it's not going to be very happy with me. Again, process name cannot be indexed. So I'm actually just going to call this, what do I want to call this? Oh yeah, empty tray. So I'm actually going to name this whole state is actually going to be called empty tray, but empty tray will start at tray 0, right? You got to give it that initial state. And then now tray 0 will be able to go to wherever it wants based on these, and then this also will define where tray 1 will go and tray 2 will go. So this is all going to be considered part of empty tray though. Okay, so that should be good. I can compile this now. I'm going to get a new error. Wait, that's actually not what I was expecting. Oh, because I fucking didn't, I got rid of this because I'm a dum-dum. Wait, actually, is that my V? That is my control V. Awesome. Okay, let's try that again. Now, we have the same thing from before. Tray 5 is defined to be an error. So right now, I'm letting it cookie no matter what this I is, right? I'm saying tray will always go to I plus 1. So if my I happens to be 4, well, now I'm going to tray 4 plus 1. I'm going to 5, and that is out of bounds. There's no way to make a infinite I. There's no way to let your variable just keep increasing. It has to have a limit. It was really confusing for me at first, because some of his questions, he's not going to mention a limit. He's going to do something like you're making a counter with which isn't really supposed to have a limit. So it gets kind of weird because you can't make it infinite. He doesn't mention a limit, but you can't make it infinite. In that case, you just have to set one. Just don't worry about it. Just set a limit. It's not a big deal. In this case, we do actually have a hard limit. So let me actually add in that. So we need to restrict this to it only happens when we have less than the max number of cookies. You can only add to the tray if your tray is not full. So we'll do as long as I is less than C, then you can add a cookie to your tray. And that should be looking pretty good now. So I can cookie, 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 cookie. Nope, no more. Right, I've added my 4 to my tray. My C was 4. And now I can bake. And now I can add some more cookies again, and I can keep baking it. So that's working. Next up, we need to add our next process. We need to add our oven. So we will add in our oven process. Our oven shouldn't need any setup like this. It doesn't really need any numbers. It doesn't have to do something a certain number of times. It's just going to be preheated, and then we can bake it, and it can cool off. So we got to pay attention to the wording here. It must be preheated, then it can bake batches or cool off. And this kind of implies, sometimes it's just, the actions are pretty intuitive as well, but clearly this implies that we cannot cool off until we've preheated. So it sounds like it's going to be kind of like what we were just talking about here, where our action, can we do large numbers? Yeah, you could just pick something massive. I wouldn't. Personally, it's just because you just pick something easy to test with, honestly. If he doesn't mention a limit, you will not lose marks for just setting it to something small like 10. It's just for testing. Obviously, as long as your process works, no matter how large you make that number, there's no issues with it. So I always just make it something small for testing and then maybe make it something a little bit larger. But I never go past like 100 for anything really, unless it tells you to. 100 is usually my representation of infinity in this course, and I never lost marks for that, so that can be your guideline. But yeah, right now we kind of have something like what I was trying to do before, where we've got A, and then we go to two options. Yeah, pretty much, basically the same thing. So I'm going to have preheat, and then I can either choose to go to bake, or I can choose to cool down and reset back to the initial state. So let's set that up. So oven will have some brackets here. It will either take preheat, and now it will be at a state where it's ready. Technically, I could make this multiple states. Maybe I'll try doing both ways. So I'll start with, or we'll call it preheated. Yeah. I think for the more complicated the word questions get, the better idea it is to separate them into multiple states rather than just trying to combine everything into one. It also just makes it easier for the TAs who are marking to see what you're doing, and you're less likely to lose marks as long as you show you had the right idea. So preheat will go to preheated. You'll do a comma, right? So the comma is for when you have multiple states for the same process. You do a dot when you're done with the process. So in this case, preheated is still, it's just another state for the oven. It's when the oven is preheated. So the preheated oven will go to, you can either bake, and then you just go back to preheated, right? Baking doesn't necessarily send you back. Right? It says you can bake multiple batches, which implies you can keep baking. You should be able to, when you see wording like this, make sure your trace that you're setting up is going to match that. We need to be able to make sure that our process can do bake, 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 bake in a row. So that's why I'm making sure we just go back to preheated so we can do bake again. Or we have cool off. And so cool off is going to go back to oven, right? It's going to go back to this. We could consider this the cool oven. And that should be good. So let me compile that now, and let's go quickly take a look in our animator. You'll see both the actions are all listed together. So anyways, I'm going to open up the oven, and we can see that I can preheat my oven, and I can't bake though, because I think the animator actually automatically composes everything, which is kind of interesting. So because the tray isn't ready to bake yet, it actually won't let me. So before I start explaining that too much, then let's at least look at our machine though. Let's look at our state diagram then. We have oven. Oven can preheat. It can bake as many times as it wants, and then it can cool off, at which point it will have to preheat again before it can bake. And that looks like our example. That's looking pretty good to me. So I think what we can do now then is, let me think about this. Are we good? Yeah. And if you wanted to actually test out your animator with just the oven, I mean, the easiest solution is just take that out for now and then paste it back in later. Also, this is so silly. When you delete something like this, the like highlighting stays until you actually, I don't even know what you have to do to fix the highlighting, but you can't, oh, Control-Z doesn't work. Oh, of course, why would Control-Z work on this program? Yeah, why? Of course. Okay. Anyways, now that I've set up my processes, we are ready to compose them. So, all we will do is we will do, I'm just going to call this whole thing cookies. So, again, two pipes at the beginning of your composition, equals, do brackets, and we'll give it the processes it wants. So I'll tell it to compose oven with, and we don't do tray, right? Our process is called empty tray. You can always check what they got called in draw if you're not quite sure what they're being named. So empty tray and oven. I'm going to compose it with both of those two. Empty tray, and put a dot on the end, and compose. And now we got cookies, and let's go test that in the animator and make sure that's making sense. So I can preheat my oven, but I can't bake yet. I can cool it off, I can keep preheating and baking, but I can't bake because I don't have a tray with cookies yet. So I can start adding some cookies to my tray. Now that I've added 4 cookies, well, I still can't bake because my oven's not preheated yet. So now I'll preheat the oven. Finally, now that I've made sure to have a full tray of cookies and the oven's preheated, I can bake. And now I gotta start adding cookies again. So maybe I can add more cookies and I can keep baking, right? I can keep adding cookies and baking as long as the oven's on. But then maybe if I cooled off, well, now once I add all my cookies, now I've got to go preheat it again before it's ready to bake. And yeah. Okay, so that is that question done. It's also kind of the end of my document. So are there any questions about that setup, about the composition, anything about shared actions? And if there's any questions from any other concepts of the assignment that we haven't covered, please feel free to ask. Because I know there's still a bit of stuff we didn't quite cover that I'm happy to go into. P equals Q. Oh yeah.
I'm sorry. I joined kind of late. This is recorded, right?
Yes, I'm recording it right now. So unless I have messed something up terribly, it should be uploaded to. We're actually. Oh, I forgot to announce this. We're doing a. We're gonna make a CSS YouTube channel. So supposedly the CSS team is going to post other things to there other than academic help sessions. I don't know how true that's gonna end up being, but
Maybe. We'll see.
We'll see. But we'll definitely
might
be
be
having
off.
some academic help videos on there. I may or may not be posting my LC3 videos from last semester as well, just because hopefully it'll be nice to have a resource where students like the next year and the year after that can keep like finding these useful videos.
Mm-hmm.
Yeah, I'm very happy to do another example too if you guys have something else you're curious about. I honestly love just like coming up with random shit to make in LTSA. I don't know why this is my obsession, is making shit in these terrible programs.
You know what I think would be good right now is possibly giving them like any insight on the Java stuff, if we have any insight.
Okay, let me quickly answer these questions. Hakeem, if you have anything to say about the Java, this is your chance to take 5 minutes to prepare. But we got some questions here, so I'm gonna look through those.
Hakeem on the spot. I'm so sorry.
But yeah, I'll call on Hakeem in a sec to say what he can about the Java questions. Let me quickly look through these. So, P equals Q implies traces P equals traces Q only when non-determinism is not allowed. This is quite the sentence. Oh, okay, so this is saying two processes are equivalent. If two processes are equivalent, it implies their traces will be the same. But I think, why does it mean by when non-determinism is not allowed? Is there any more context from the slide that you found that on, Philip? I'm curious. Determinism is basically just saying there's only one way to go through a process. Like, you know how our array question, or even the, no, yeah, let's go with our array question. I had the option of at any point in the array either finding my value or going to the next value. That's non-determinism. If you have a process like the light switch, where at every spot you only have one option, you have to go on and you have to go off and so forth, that's determinism. At least that's my understanding of the word in this course typically. Thinks the 20% take-home sentence means 20% of the 20% is done online, but 80% is done in person. That is 20% comma. It's not 20% you take home, that's 20% comma take home, comma virtual. So, no, it's worth 20%. Yeah, there's a notable comma there that changes the meaning of that sentence. Yeah, ours was entirely virtual. Ours was just, you were given, you had a bunch of questions to go through. I don't remember how many, I think it was like 7. And it was all online. You just submitted the Dropbox would close right at the end of the time, so you had to submit your PDF before then. The array of adjectives. Okay, let's look at this. So, yeah, determinism is only one way to move from state to states, like dough, baked, yummy cookie. Yep. Non-determinism is, yeah, you've kind of got some options. Okay. When non-determinism is allowed, it does not preserve the composition operator. Oh, so here they're saying it's a double implication. Okay. So I wonder, it might just be in that case, maybe only one direction breaks when non-determinism... What? I hate the way it says non-determinism is not allowed. So it means when determinism is forced. Yeah, so it's saying this is only true when determinism is true. And then, yeah, what is this preserve meaning? Does not preserve the composition operator. No, I think it's saying it only works with determinism, right? It's saying it works if non-determinism is not allowed, double negative. It works if determinism is forced, if it is deterministic. That made more sense to me. When I was reading your thing, I was like, why would non-determinism make a property work? Like, but I also read it wrong. Yeah, you had the double negative in yours too. Yeah. Like, you'd expect non-determinism to break any property that currently works with determinism, and you would never expect the other way around to work. Yeah, okay, was there anything else I had to answer here? Okay, and then another example. A phone can be used when battery is charged. Battery must be at least 10% to use phone. Yeah, you could do something like that. Okay, Hakeem, first, would you like to talk about the Java question at all, if you have anything to say for that?
Yeah, sure. Okay, quick question. For the people who've taken this class, or who are taking this class right now, was there any mention of any graphical components? Like,
Nope.
Was there any mention at all about the question?
In the assignment, it definitely said there should be, or it said it was optional, right? It was like you may optionally have a graphic component, and apparently the TAs have confirmed that they don't need to do that. They don't need to have the graphic component.
Okay, that's cool. Okay, yeah, okay. So for the Java question, I think all they're just looking for, at least from before, was that you ideally have a class that models the radio in this instance, and have all of its actions be methods, and then kind of create some control flow logic that models the sequential process of the radio, and then you can use print statements as well to achieve this, so that it looks like you're interacting with the radio, if you're not going to do a graphical component.
Would you use prints to just print out the actions, or more are you coding like a real radio, basically?
It's more so coding than actual radio. Like,
okay.
It's like within their specification.
Yeah. What would model the states? I think states are actually meant to model basically what state other variables of the program are at, right? That's typically what states are, to model all the different cases you could have for your variables. So you're kind of going back to that. You're now just going to have actual variables that model, or that restrict your actions and what can happen next.
Yeah, what I will say is that you can use enums to, if you know what enums are in Java, you can use them to model the current state.
That is also an option. Or you could just have a state variable that is just a number.
Yeah.
But another option is sometimes it might be more intuitive to actually just have, like for our array, when I was doing the array example, we kept going between a bunch of different array states that modeled what index we're at. It might be more intuitive to just kind of have an index variable and work with that. And I think that's fine. I don't know. Hakeem, do you think it's more like safe to make sure you have an actual state variable, or do you think it's fine if you don't, as long as the traces are correct? I'm curious.
I would say, just to be safe, probably create a state variable.
That's fair. Yeah. I started talking and then I was like, wait, maybe this actually doesn't make sense. Yeah, I think probably to be safe, because we know that, like, well, you know that you got full marks for solutions in the past that, like, used a state variable. So I think it's fair to assume that that's fair game. That just have maybe have a state variable, just a number or an enum that models what state you're on. If you're going to use numbers, perhaps have some comments listing what number or what state each number represents. Can never be too safe with coding questions.
Yeah, I would say that this question is very weird, and it's just like put in like randomly. Like, don't spend too much time on this question. It shouldn't be too complicated.
Yeah, I agree with that. Yeah, the radio just has to do what the FSP describes, pretty much. Except doing stuff is just going to be print statements. Yep, I think that sounds about right. Yeah, so each of your different actions should be like a method, or like a function in the class. Oh.
Yeah, exactly. And make sure that you have input from the user as well. So you're able to like put in like...
Right, that's the big difference. Is it's now like the user is actually controlling it properly compared to our FSP, where it's just kind of mapping the possible actions that can happen at any point. So that's part of the making a proper radio. Your user needs to actually input, like, do they keep scanning, do they reset, whatever. FSP is short for finite state process, and it's basically just the text representation of a process. So essentially it's just these. It's just this that we're writing here. Or the text stuff you see in the slides. Like this. An FSP is just when you see stuff written like this, where it's just a process written as a sequence of actions you can take. Yeah, like input from the terminal. Yeah, I don't know how else you'd really. Yeah, if you do some kind of GUI route, then you could have buttons you click, I suppose. But the simplest way is definitely just terminal, read line input. Okay, hang on, where was this? Here we go. Here, I don't know why I was blind for so long. Okay, I'm just gonna go through this example in LTSA. I'm gonna try to make this the phone battery. So let's give this a little go. Okay, oh, you know what I should also do is quickly copy this and drop this into the document. Alright. Okay. So, let's give this a try. We have a phone that can be used when a battery is charged, and the battery must be at least 10%, it must be at least 10% to use the phone. Okay, Turtle Cuban, should I make this as a composition of like a phone and a charger? Or is it just a phone? It's got a battery level. I'm assuming we're using battery level as the variable. And do you want me to just make it its own separate process that just has a charge action that's independent of any kind of charger? Yeah, why not? We'll toss a little charger in there, perhaps. Charger must be plugged in to use. Awesome. Okay, we'll have plug and unplug. How about that? All right. So we'll start off then with phone. We'll have phone equals. And let me think here. Phone equals. Okay, so phone is gonna need a battery level. Let me tab back out of this for now. Or no, I'll keep this open, I guess. Okay, we got a lot of yappers in the channel though. All right. So I'll do phone. We'll give it. We'll keep I. I usually use I for my variables. Should it be an off state first? So okay, so phone has to be turned on as well. Yeah. Okay. So how about we'll say on can be equal to the phone when it's being used. So phone, like, I gotta think about this. What battery level do you want to send it to when you turn it on or off, though? I guess. Okay, for the initial state of the machine, here's what we'll do. It'll keep its battery. For the initial state, we'll keep it at maybe 0. Let's see how this goes. We'll do 0. Actually, I don't know. When you buy a phone, is it full? Probably at full, right? I don't think if you buy a phone, is it just dead? I don't know. I can't remember last time I bought a new phone. So I have a bit of a plan. We're gonna probably have the on-off states or on-off transitions done in 2 different spots. Actually, that may be dumb. But I have an idea. Essentially, what we need to do is the off state also needs to keep track of a battery. Just because it's off doesn't mean it doesn't have a battery. And that should be fine. And we'll let it turn on or off. We could say that if the battery is below 10, maybe it just goes to off, you know? And maybe you can only turn it to on if it has enough battery. That probably makes sense, right? Setting up these new problems is always kind of interesting. That's what I like about LTSA. It's kind of fun in a way. It's some puzzles. Let me think. So it'll be battery will be between 0 and 100, and we could set something up where maybe off. Maybe this is off actually. It's just phone. And then maybe we have an on state where you can actually use it. Maybe we'll do this. So off is phone 100. Phone does all this. And then we'll enter this down a bit. So when I like to do a space here. So I'm thinking when I is greater than 10, then on will go to on, and we need to preserve the battery. This is actually really useful, is you can have multiple states that preserve that same I variable. So we'll have another state on, which will have the exact same range. See this? No, actually no, it won't, right? On only has that range, actually. And then we'll just make sure that when we turn it on, we preserve the battery. We're just gonna pass it the exact same variable. And this can be a different letter, right? This could be J. I usually keep it the same if it represents the same thing and change it if it represents something different. You can also make this a full word. It doesn't just have to be a letter. So we could call it battery. Maybe we will. Maybe we will call it battery. You know what? Why not? Let's call it battery. Maybe this will make a bit more sense here. Let's call it battery. All right. And when battery is greater than 10. Oh, yeah. So that's one option. Actually, that's kind of the only thing you can do if it's off, isn't it? You can turn it off. Maybe we also have charge. We also gotta have charge. Charge. We'll go to. How do you want to do this? Just charge increases it by 1. Probably works. I think we'll just do charge goes to phone. That's actually gonna be terrible if we're trying to test this and I have to like charge and it just goes all the way down by 1 each time. Maybe, how about it goes in increments of 10? How about that? Yeah, I'm thinking 5 or 10 probably makes a bit more sense. So you charge it by increments of 10 at a time. And let's do some other stuff. Let's do, we also gotta have, how does the battery run out? Should there just be an action that just depletes the battery? Play games? Oh, that's a good idea. Okay. How about use? Maybe I should just call it, oh, actually, so it shouldn't be able to go out while it's off. You shouldn't lose power while it's off. But what we can do is, I can do it's part of the on state, and we can separate this a little bit. We can enter a line down, I think. It should be fine. We can do a bit of that. So while it's on, let's define some actions that will actually lose us some power. So how about use will go to on, where we have battery minus 10, so you lose 10 for using it. Now we're gonna need some restrictions here because this is clearly gonna let it go to on lower than it should. So maybe we need to do this. We need to do when. First of all, I need to stop it from going out of range, so it should only be when battery is more than, I guess, we'll just do more than 10, because technically it can't really, if it's at 20, then you can go down, that's fine. And you can't really be at any number between that. So that should work fine for restricting the behavior we want. Yeah, I just wanted to make sure I wasn't letting it actually get to 0. Not just letting it, I'm not only worried about negative. And then we need something else. We need to say when the battery is equal to 10, right? When you're at that limit, then use will actually send it to off 0. See the idea there? So if you use it at the limit, then you're actually, it's going to be completely dead, and we send it to the off state instead. Oh, but off is actually set to phone 0. So sorry, it should be, maybe it should be like this after all. It should be like phone. Phone is equal to like off 0. Starts at off, but it's at max. And then maybe this can be off. How about that? So off is the one with the level. We've got on and off. Those are our 2 states with the level. And phone is just the name of the whole process. I think this is starting to look pretty good. Do you think this will compose? Okay, I'm getting numbers I shouldn't. I'm definitely getting numbers I shouldn't. I think that's because of charge doesn't have a cap. So we can only charge when battery is less than 100. That should be fine. It's still actually being able to get to off 101 and all that. You know what I think is interesting is even though I said that it won't, like, technically this is never possible for it to get to, like, it can't get to 11, right? It can't be at 11, so it can't bypass the limit. But I think it's going to have that issue anyways. Well, my idea, Luis, was that we would never be able to get to 99. But I think you're right. Because I was thinking we'd never be able to get to 99, so you could only be at, you could be at 90, right? You could get to 90, and then you could increase it past that and get to 100, but at that point you can't do it anymore. But I think what it does is it actually tries to test to make sure that off for all possible values here doesn't have any errors. That's what it's trying to check for. So in that case, you're right, we need to fix these restrictions a little bit. It should be if it's less than equal, that's not how you do less than equal. If it's less than equal 90, and then this should, I think, be greater or equal to 20. Will that work now? Awesome. Cool. Let's go test out our little animator. So I can power it on. Wait, where the focus play? Yo. Oh, it's use. Did I have use? Oh, I do have use. Okay, okay. Alright, we got on. We can use it a bunch, and we're going to deplete its power. And now I can't use it anymore, so I'll have to charge it. I have to charge it twice, interestingly. Oh, on should have, yeah, on should also be allowing it to charge. You're right. I should be able to charge it while it's on. And then right now, because right now I think you can only, when can I charge it? Oh, okay, I can charge it when only when it's off. You're right. And I was able to use all the way. So at this point, I've used it what? It was at 100, 90, 80, 70, 60, 50, 40, 30, 20, 10, 0. So it's fully at 0. And then I charge it. And at this point, why? Oh, you can only, oh, I did greater than 10. Okay, I wasn't letting you turn it on when it's actually at 10, which we should do, right? We said it's, I think it's at 10 is fine. You can use it. And then, yeah, we've still got to add some stuff. So this is, I wanted to show this because it's nice to see how the animator lets you understand exactly which behaviors you're missing. The animator is your most powerful tool when you're doing these types of questions to see exactly what behaviors of the original or of the intended scenario you're not modeling. It's so much better than, look at how messy, look at this. Look at how garbage this diagram has become by now. This is actually horrible. Like, what? Can you imagine trying to look at this, be like, does this render my process? So, yeah, let's fix this. Okay, so when it's on, you should be able to charge it, of course. So we can probably just steal the exact same, thing there. Oops, I did not copy that right at all. Okay, and then instead of off, we want this to still be on with more battery. So that seems good. I can't actually turn it off at the moment, so that should probably be a thing too. At any point, off will take you to off with the same battery level. What do we think? Am I missing anything else? I can now turn it on. I can use it a bunch. I can turn it off. I can turn it back on. Should be charging it any time, so now it's back at full. I can use it to the max. Now I can charge it. As soon as I charge it, I can turn it back on again. Now I can use it. It's off again. I can charge, and so forth. Okay. Well, I think that's looking pretty good. Am I missing any behaviors or what? Do you think it's done? We got a phone. There we go. Oh my god, the highlight is terrible. Why does it do this? You have to manually go to every single line and change something for it to fix this highlight. It's actually horrendous that it does this. Oh my god, that's foul. Why is it programmed this way? Oh, okay. Oh, that's actually a nice trick. If you move the whole section of lines up like with something properly, like an enter, then it fixes it. Okay. So I'm just going to. Oh, we were gonna do a charger, weren't we? We were gonna do a cute little charger. So we gotta have another process. We gotta have a charger where we can unplug and plug him in, and he can charge. How did I get the animator to work? It just seems to go to your old previous FSP. So make sure you click the C button to compile. To create that, as soon as you click compile, the animator should now be set up with your newest FSP you've put in here. Were you clicking that button, or? It's just the little C button at the top. Yeah, make sure you click that when you're done. This is just your save button in classic compile. Okay, so we'll quickly set up a charger here. Let's do. I'm trying to think, because I'll need, like, the charger needs a plugged and unplugged state. I think I'm just gonna do. I'm probably gonna have like an unplugged. I'll have like an unplugged as well. I'm already having that set up. When it's unplugged, the only option is plug, and then it goes to charger. Sometimes it's not necessary to have your states called unplugged and plugged. Charger can just represent the plugged state. That's fine. And then when it's plugged in, you can unplug and go to unplugged. Right now I've basically got an on-off switch. This is a very common pattern. Or I've got my useful thing. So an on-off switch with a useful thing only in the on state is another very common pattern. I will have charge. And then back to charger, right? It stays plugged in. This is very much like our oven that you could preheat and all that. Okay, so we can compile, and now you don't even need that compose line at the bottom. You can just click compose, and it'll automatically make a composition between the two, and we can give it a try. So now I'm running, and as soon as you click composition, the animator is now linked to the composition of the two. If I just click compile, I think it is actually already also linked to the composition of the two, which is interesting. Wait, yeah, because I click compile, and then look what happens when I click the animator. It's basically the same as clicking the composition button. If you have multiple processes, it will compose them, which is actually kind of neat. I didn't realize that until just now. Okay. And we can see our machine, kind of. No, we actually can't. Oh, because we didn't compose, technically it doesn't give us the machine, though. Oh, lovely. Oh, boy. I can't even... Oh, my God. Yeah, what a machine. Oh, my... That's beautiful. That's a work of art. Yeah, the animator is your best friend. Okay. So it actually starts plugged in, which is probably a mistake. We should probably make it... Actually, so maybe I do want to do this after. Maybe I do want to do charger goes to unplugged. And then... plugged can be equal to all this, and I'll just quickly toss plugged into these two, and that probably makes the most sense for how to set this up. Compose, animate it again. There we go. I can turn it on, and I can use it a bunch until it's dead, and now I can't charge it. I have to make sure I plug in my charger first, and I can start to charge it. Then if I unplug, I can't charge anymore. I gotta plug it back in, make sure I charge, and that's our composition done. So I'll just drop that one in the chat, I suppose. It's like a funky... Yeah, it really is. They really all are like funky solar systems. It's lovely. What is going on? Me with my 5 billion plug moons. It's amazing. Okay. Do we have any other questions? Otherwise, I think we might be at a good point to stop. It's almost 9. I'll hang out until at least 9, though, even if there's no questions. But I feel like I got through all the content I kind of wanted to cover. I mostly just wanted to give a really good rundown of LTSA, because I know for the first time, tackling word problems like this is very, very confusing. When I put the big capital words in front of brackets. Okay, so think of that as, I kind of explained that at the beginning. I'm not sure if you were there for that. It was at the very, very beginning, I think. Think of that as being basically shorthand for writing out this. Writing out off 0. So, or maybe like if it makes more sense, you can call it like that. Like, don't worry about the square brackets. The square brackets, for the record, just puts a dot. It just puts, it'll literally turn it into off dot 0 is like this, is that right? Sorry. This is just a state the same way this is. But it's when you put brackets on an action, it will actually be the same as doing a dot on it. You'll see that in the animator. Yeah, I think it probably is the same as that. It's like labeling it. So what I'm doing is, instead of trying to define all these different states for what happens when you're off, when you have like different levels of battery, instead of trying to write out all of these and then giving them all like, oh, you know, this can do these actions and so forth, and then this can do the same thing, but, you know, instead it takes you to 2, and, you know, maybe this one has, like, charge takes you to off, like 10, you know? Like, we'd have that programmed in. And then here I would do the same thing, but I would literally have to change it to, oh, this one takes you to off 11. Oh, and then this one does the same thing. Oh, but it takes you to off 12. Imagine doing that 100 times. Instead, what we can do is you can automate that by declaring a variable and setting up your numbers and just telling it to do something based on that variable. Tell it to do a bit of math. And it will figure out the rest. But you have to add some restrictions to make sure, otherwise it'll tell you, oh, you've done an error because you've actually said that I is only supposed to be between 1 and 10, but you just told me that I 5, for example, if we see this as I is 5, if I do this of I 5, then it's going to try to set it to 5 plus 10 and go to 15, but that was out of my original range, so it's not going to like that very much. So you just have to make sure you set up the correct conditions with the when like this, to make sure that you are not letting your variables go out of range. It's just one of the biggest things to focus on when working with these like variable index problems, is keeping your variables in range. And thankfully it gives you very nice output errors telling you exactly where it's going out of range and at what values. And yeah. And just keep in mind, it's not smart enough to check the values that are, like, remember before I was saying I only had it as battery less than 100 because I knew the battery could never get to 91. So in theory, less than equal to 90 and less than 100 are the same if it's only going by increments of 10. There's no difference between less than equal to 90 and less than 100 if I can't access those values between 100 and 90. But this thing doesn't care. It just rigorously tests every single possible value to make sure there's no way to get to an error state. So even though we can never access state like battery equals 91, it still tests battery equals 91 and realizes it goes to 101 and causes an issue. So I hope that answers any questions about the indexing and the brackets and all that. Yeah. And so you don't always have to give it a variable in here. You can give it a static number too. Just like we're doing up here, if you ever need to go to a specific, like, oh, this thing doesn't necessarily change the variable, it just always sets you to exactly 0, that's not a problem. You can toss real numbers in here at any time, and that'll be the value that gets fed to battery. I'm truly the king of obscure languages. I don't know what it is, I have so much fun working with these, like, whenever we have a course involving them. I love working with, like, new stuff that's so unexplored. It's like, there's something really boring to me. You know what's funny? I play a lot of, like, weird games, but a lot of people are always like, oh, you should play chess. Like, oh, you should get into competitive chess. But chess to me seems so boring because I know that, like, the best way to get good at chess is probably just, like, reading up on all these resources people have, because that game is, like, there's known ways to open, like, all the openings are known, stuff like that, you know? Like, I feel like I would get so bored of reading, like, conclusions that someone else came to, and it's so fun for me to explore, like, unexplored territory like this, where no one knows what the right way to do these are half the time. Like, you're learning the process for making these and solving these problems by yourself. That to me is so much more fun. I feel that my goal is, because I couldn't 12 this course, I need to make sure someone does. So, I've got high hopes for you, you know? Don't let me down.
Actually, wait real quick before people start leaving, because I
Yeah.
realized people started leaving. I'm gonna post a feedback form soon. I would love if people filled out the feedback form, please. That's all I had to say.
Guys, it'd be really funny if no one filled out the feedback form.
Oh my god, Jacob. See, the reasons like this is why I'm gonna fire Jacob.
You can't fire me. Who's gonna do
I
this?
know.
Who's gonna sit here and LTSA for 2 hours?
I'll get someone else. No, I'm joking. Guys, Jacob is too valuable to lose. But
You
Fill out
should
the
probably
feedback
fill out the
form, okay?
feedback form. We would appreciate if you filled out the feedback form.
Please fill out the feedback form.